This is a revision video for triple students only, and it's about transformers. So what transformers are a big iron square shape with a gap in the middle. So this bit in the middle is a gap. And the transformers are made out of iron, and we'll go into reason why in a minute. What we have on the left hand side is we have wrapped coil, and on the other side we have wrapped coil. On this side I'm going to wrap more around. I'll explain what type of transformer that is in a minute. So what we call this is the primary. Primary means first, so it's the primary coil. And what happens, alternating current goes into that primary coil. Alternating current goes into that primary coil and it magnetizes this iron core. The iron core gets magnetized and demagnetized very quickly. So what it does is it transfers the magnetism through the iron core. And because this magnetizes and demagnetizes very easily, very quickly, it induces a potential difference over this side in the secondary coil. And it's secondary because it's second. And because we've got this changing magnetic field, it induces potential difference. And if it's part of a circuit, we generate current. But you can, when I drew the coils, I drew 3 on the left and I drew about 10 on the right. What this does is it increases the potential difference. So let's just go through this transformer again. Alternating current in, AC in, and what this does is it generates, magnetizes the iron. It magnetizes and demagnetizes the iron. And what we can say is this iron core is soft. The iron core is soft, which means it's easily magnetized. And what this does is it creates a magnetic field within this coil. Creates magnetic field inside the coil of the secondary coil. And if the secondary coil is part of a complete circuit, we generate a current. And because we had alternating current in, we get alternating current out. AC in, AC out. Because we've got more secondary coils to primary coils, it's a step up transformer. So secondary coil more than primary equals step up transformer. And a step up transformer increases the potential difference. It increases the potential difference. But if we've got a transformer that has more coils on the primary, so let's draw one again. 2, 3, 4, 5, 6. We've got 6 coils on the primary. This time it's only got 2 on the secondary. Alternating current comes in, creates a small magnetic field which magnetizes and demagnetizes the iron core, which transfers the magnetic field, which induces a potential difference, part of the same circuit. This induced potential generates a current, but because we've got less coils on the secondary, it is a step down transformer. Secondary coil got less than the primary, so that's a step down transformer, and that decreases the potential difference. So transformers always utilise alternating current. It magnetizes and demagnetizes the iron core quickly, which induces potential difference in the secondary coil. Because it's part of a complete circuit, we get a current, and we can work out what happens to the potential difference if we know the number of coils. So the equation we need is V, potential difference, of the primary divided by the potential difference of the secondary, and that's equal to the number of turns on the primary coil divided by the number of turns on the secondary coil. What's good about this equation is it's a ratio. The ratio between the primary and the secondary equals the ratio of primary and secondary, so the equation actually works upside down as well. So the potential difference on the secondary coil divided by the potential on the primary coil equals the number of turns on the secondary divided by the number of turns on the primary. And like any equation, my advice is always to substitute the numbers in first, then rearrange, and then get an answer. Don't take any shortcuts. And what's really good about iron core transformers is they're nearly 100% efficient. Because they're nearly 100% efficient, the power transfer is nearly 100%. And if you think back to our electricity unit, power equals current times potential difference. So we've got power of the primary, and we can have power of the secondary. And instead of saying power of the primary equals current times potential difference, power of the secondary equals current times potential difference, we can rewrite that equation and get rid of the p's entirely. So what we can have is the potential difference of the secondary coil times the current of the secondary coil is exactly the same as the potential difference of the primary coil times by the current of the primary coil, because the power before and the power after are equal because it's 100% efficient. Once we've got the equation like this, we can put in our, whether it's our secondary potential or primary potential or current at the secondary coil or current at the primary coil, whatever these numbers are, we can put 3 of the 4 of them in, we can simplify, we can rearrange and find our missing value.